Moving on to 7.2 part 2, we are going to talk about the double angle identities. So again, on your formula sheet, there is a list of all the double angle identities. There's double angle identities for sine, there's 3 for cosine, which we'll talk about, and then there is 2-ish for tan. But what I want to do is just show you again that these identities don't just come out of thin air. They're developed and then you can use them. So the double angle identities actually come from, again, the sum and difference identities. So sine of 2x would be equivalent to the sine of x plus x, right? X plus x is 2x. If I was to use my sum identity, I would say the sine of x times the cos of x plus, because you match your sine, the cos of the first angle x times the sine of the second angle x. I've got sine x cos x plus cos x sine x, which really is just sine x cos x. So I have 2 sine x cos x. So if you go to your formula sheet, there it is. Sine of 2x is equal to 2 sine x cos x. So they've done that for all of your trig functions. So now we have cos 2x. Now it's equal to cos squared x minus sine squared x, but it's also equal to these other two, because they've used your Pythagorean identities to, maybe replace sine squared x with 1 minus cos squared x, and then they can come up with this, and so on and so forth. And then tan 2x has its own identity. As well, you can write tan in terms of sine and cosine. So let's look at what a question would be. So it'll say something like, given that tan theta is -3/4, theta is in quadrant 2, find each of the following: sine 2 theta, cos 2 theta, tan 2 theta, and which quadrant 2 theta lies. So I've got a process here. I've got some steps that you can do, but I'll get to them. So what it is that you're going to take the information that tan theta is equal to this and try to evaluate sine 2 theta. So we know that sine 2 theta is equivalent to 2 sine theta cos theta. Well, they didn't give me sine theta cos theta, they gave me tan theta. So that's why step 1 is to draw the angle from the given information. So the given information is that tan is -3/4. Now, if we think back to our cast rule, tan is negative in quadrants 2 and quadrant 4. So because of that, what they'll always do is tell you which quadrant to put your answer in. So they've told me to draw my angle in quadrant 2. So if tan theta is equal to -3/4, tan theta, we know, is y over x or opposite over adjacent, right? Whichever one. So we know that this is going to be opposite is 3, or y is 3, and that the x is 4, or the adjacent is 4. And then we have to figure out, where do we put that negative? So it's a negative fraction, which means either the 3 or the 4 is negative. Because the x is in a negative direction, we know that the 4 is negative. So to be able to find out what sine theta is and what cos theta is, we need to figure out the hypotenuse of this triangle. So we're going to use Pythagorean theorem. We're going to say that this side r, right, is equal to, so r squared is equal to 3 squared plus -4 squared. That was a horrible 4. Okay, so r squared is equal to 9 plus 16, which is 25. So then to solve for r, we're going to take the square root of 25. Remember, anytime you take a square root to get an answer, there's 2 answers, positive or negative. Now, because we are in quadrant 2, actually it's not even because we're in quadrant 2, it's because it's the radius. Actually, I'm going to write that. So because it's the radius is always positive. So we know that our radius will be positive 5. Okay, so what does that mean? Well, it means that sine theta, so this is theta, is opposite over hypotenuse, or y over r, which is 3 over 5. The cos of theta is going to be adjacent over hypotenuse, or x over r. And then we already know that tan theta is equal to -3/4. Okay, so now we can use this information to evaluate sine 2 theta. So we can replace the sine theta with 3/5, and we can replace the cos theta with -4/5. Okay, now we're just going to multiply. So we're going to multiply across the top. 2 times 3 is 6, times -4 is -24. 1 times 5 times 5 is 25. So the value of sine 2 theta is -24/5. Now we're going to move on to cos 2 theta. So cos 2 theta, we're going to use one of the double angle identities from your formula sheet. We've got cos squared x minus sine squared x. We've got 1 minus 2 sine squared x, and we've got 2 cos squared x minus 1. They're all equivalent, so it doesn't matter which one you use. They will all give you the same answer. Now, I'm going to choose the first one because I know if I choose it, I'm going to end up with a common denominator. So I'm going to use cos squared x minus sine squared x. So cos squared theta, I should say, minus sine squared theta. Okay, so now what I can do is I can replace the cos theta with -4/5. So this is, remember, anytime it's cos squared theta, it means that cos theta is being squared. So maybe it'll help if I write it. It's cos theta that's being squared minus the sine theta that's being squared. So I'm going to replace the cos theta with -4/5. And I'm going to replace the sine theta with 3/5. Okay, then we're going to square it. So we've got -4 squared is 16 over 5 squared, which is 25, minus 3 squared, which is 9, over 5 squared, which is 25. So that would simplify to 7 over 25. Okay, so we've done part B, now we're going to move on to part C. Part C is to find the value of tan 2 theta. So I'm going to do that over here. So the tan of 2 theta. Now again, we have two options for this, and I by no means have these memorized, so I've got to bring up my formula sheet. Option number one is that tan 2 theta is equal to 2 tan theta over 1 minus tan squared theta. So we could do it like this, and we could plug it in. So I got to remember what this is. It was 2 tan theta over 1 minus tan squared theta. Okay, so we could fill into here, right? We could say that tan theta is -3/4 over 1 minus -3/4 squared. And then we could keep going. Ugh. Okay, so we've got 2 times 2 over 1 times -3/4. So that would give me -6 over 4, which I could have simplified first, right? So 2 goes into itself once and into 4 twice. So I end up with -3/2 on the top. If I went too quick with that, do it on the side. 2 over 1 times -3/4. Whether you simplify first or get -6 over 4, and then it simplifies to -3/2, right? And then in my denominator, I have 1 minus 9/16. Oh, I'm regretting showing you this one. And so then on my top, I have -3/2. On the bottom, it's not that bad. I have 1 minus 9/16. 1 minus 9/16. So 1 with a common denominator of 16 would be 16 over 16, which is 7/16. Now I'm going to write that as a division. -3/2 divided by 7/16 is the same as -3/2 times 16/7. Oh, this is horrible. Okay, 2 goes into itself once and into 16 8 times, and I'm left with -24 over 7. Oh, that was awkward. It wasn't awkward, but it's awkward when I show you what we could have done. So this was us using the double angle identity that's specific for tan. But this question already made us find sine 2 theta and cos 2 theta. So if I had done this one, instead of using, like if this question had these 3 parts and you had already found sine 2 theta and cos 2 theta, you wouldn't have had to do this whole thing. What you could have done is said that tan 2 theta is equal to sine 2 theta over cos 2 theta, which is equal to, now the sine of 2 theta we found was -24 over 25, and the cos of 2 theta was 7 over 25. So that's -24 over 25 divided by 7 over 25, or you could multiply the compound fraction by 25 over 25, right? You'd end up with -24 over 25 times 25 over 7. Boom, boom. We get -24 over 7. So again, tan, you could have used the proper trig identity that they give you for double angle, which is 2 tan theta over 1 minus tan squared theta. But if in a question they ask you to find everything, and you already have sine 2 theta and cos 2 theta, feel free to use this, right? You don't have to go through all this. And it's only more complicated because there's more fractions. But this one's already kind of done for you. And then part D, it says, what quadrant does angle 2 theta lie in? Well, how are we supposed to know that? So without solving for theta, right, or 2 theta, what we want to do is look at whether things are positive and negative. So we found that the sine value, so the sine of 2 theta was negative. We don't care what it was. We found that the cos of 2 theta was positive, and we found that the tan of 2 theta was also negative. In other words, if we look at the cast rule, the only quadrant where cosine is the only thing positive is quadrant 4. All right, go and try some of these.